For all of the individual charges and pairs of charges that we drew electric field lines for earlier, we now want to draw the equipotential surfaces. So the equipotential surface is a line or a surface where every point along that line is at an equal potential. So when you have a single charge, it's pretty basic because the potential is the same at concentric circles or concentric spheres around the charge. So the equipotential surfaces for these ones will just look like circles around the charge. And you can draw as many or as few as you want. It just all means that everywhere in that circle has the same potential. So it's actually going to look the same for all four of these individual charges. They should just be concentric circles. And you don't have to draw any more or any less depending on whether it's double the charge or half as much charge. They're just all equipotential surfaces. When you get to pairs of charges, it's a little bit different. When you have one positive and one negative, there's an equipotential line if they're of equal magnitude, as in this case with the positive Q and the negative Q. There's an equipotential line right down the middle between them, because every point along this line is the same distance from this charge and from this charge. So there's a positive potential contributed by this charge at any given point and a negative potential contributed by that charge. So every point on this line is going to have a potential of 0 because it'll be cancelled out by the two charges. And the remaining equipotential surfaces will just be not quite circles, but things that kind of more like sort of like ellipses that just kind of span out a little bit further on either side. And same for the other charge. When you have a positive and a negative charge where one is a little bit bigger than the other, instead of having a line down the middle, now the line is going to be kind of curved and pushed more toward the smaller charge. So this might be that one line that's the equivalent of that one line down the middle. This would be the line where all the potential along that line is equal to 0. So, and the rest of the charges will look fairly similar. When you have two positive charges, the equipotential surfaces, as you're close to the charges, they're just kind of circles around the charges. But as you get a little bit further out, it's actually a surface that kind of wraps around both charges, kind of like this. And a similar looking thing when you have two charges of the same sign, but where one's a little bit bigger than the other one, except it's going to be asymmetrical. So it'll look something more like this. Where around the 2Q is bigger than around the Q.